Question 1, core 1, bronze sequences and series. So press pause, let's write this question down and answer which one is arithmetic and which is geometric on 1 to 5. So basically, an arithmetic series, the difference is basically adding a plus or a minus in between each term. A geometric is a ratio, a multiplication, or division. So this one, first of all, 1, 5, 50, 20. This is adding 5s, therefore it's an arithmetic series. I'll put A for arithmetic. Number 2, 3, 6, 12. This has been multiplied by a ratio of 2, so I'll put G for geometric over here. Next one over here, 12, 6, 3, 1.5. This is being divided by 2, so again, this is geometric series. We're timesing by half, same thing. We tend to use times by half, by the way, so ratio for number 3. Number 4, we're adding 5 each time, so this will be an arithmetic series as well. What is the fundamental difference between an arithmetic and geometric series? Well, we just said at the beginning, arithmetic tends to add or take away, and this tends to multiply it by a ratio. It could be above 1 or less than 1. If it's less than 1, it could be division, but we tend to put times 0 point something. Question 2, core 2, bronze. Let's press pause, write this question down, press play when you've done parts A and B. So the first number of arithmetic sequence is 4. This is an arithmetic series, which means it goes up or down by plus and minus. Okay, that's 4. The difference is 6. So the question is, state the 50th number in this sequence. So you should know that this is the formula for the arithmetic series of the nth term. It'll be as such over here. So a plus n minus 1d. Okay, so A1 is the first term and d is the difference over here. So let's write that down. This is the yellow one, this is the green one over here. So the 50th term, we simply plug in this value over here for A50. A50 equals, now the first term is 4 plus n minus 1. N is the term in the sequence, d is 6. Okay, so this is the same thing as saying 4 plus 6n minus 1, which is the same thing as saying 4 plus, multiply out the brackets, 6n minus 6. So therefore, 4 minus 6 plus 6n is the answer, and therefore the answer is 6n minus 2. So the nth term is 6n minus 2. That's how to find the sequence of anything within the arithmetic series over here. Part B, let's now find the sum of the first 50 numbers. So for this one, you should know as well, this is the formula for this over here. So Sn equals, it's n over 2. And this will be 2 A1 plus n minus 1d. Okay, so let's plug these numbers in again over here. So we want to find the 15 over 7, 15 over 2 rather. Okay, and this is going to be 2 times A1. A1 was 4, obviously. 2 times 4 over here, plus we've got 15 minus 1, and difference is 6 over here. So this will give us, this is a times by the way, this will give us now 7.5 over here, and this will be 8 plus, now 15 take away 1 is 14, 14 times 6, this would give us 84. Okay, so this is like saying 7.5 times 92. So if one does that, 92 times 75 on long multiplication, 2 times 5 is 10, 5 times 15, 5 times 9 is 45, plus the 1, 6, add the 0, 2 times 7 is 14, 9 times 7 is 63, plus the 1, 64, add them together, we get 0, we get 10, we get 9, and we get 6. Take it back one decimal place over here, because this is going to be 1 dp. So we get an answer of 690. So the answer would be 690 for this arithmetic series, the first 15 terms in this. Make sure you understand how to multiply by decimals for the last bit, and obviously the formula, which we just stated over here as well. Question 3, core 3, bronze sequences and series. So let's write parts A and B down. Let's find the nth term and the summation of this geometric progression. Press play when you're ready. Part A, so the first number of a geometric series is 3, okay? And the ratio is going to be 2. So let's call this a different colour, maybe this one over here. State the 6th term in the sequence, okay, with the formula. So the formula for the nth term of a geometric series, so Gn equals G1, and this will be R, and it will be N minus 1, okay? This is the formula we need to use. So we want the 6th term over here. So the first term will be 3. So 3 is this yellow one over here. And the ratio is 2, which is over here. This is what we multiply it by each time. We multiply each term by 2 in this progression. So it'll be 3 first of all times. This will be 2 to the power of 6 take away 1. Okay, this is the same thing as saying 3 2 to the power 5. So let's do the indices first. Obviously for big mass, I comes before m, so indices 2 to the power 5 is 32. 3 times 32, the answer is going to be 96. So the 6th term in this sequence. You can test it as well if you wanted to, by going up and timesing each number in this progression by 2. Anyway, find the sum of the first 6 numbers. Okay, so again, it's the formula we need to know for this one. So Gn equals a G1. Now, if the ratio is above 1, we're going to use this formula over here. R to the power of n, take away 1 over R, take away 1. Okay, so that's if R is greater than 1, we use this. If it's less than 1, well, we simply switch them around. We 1 take away R to the power of n over 1 minus R. But anyway, let's use this formula over here. So let's plug in our values again. So we have the first term being this one over here, and the ratio being this one as well over there. Okay, so we've got first term being 3. Okay, now R is 2. Now 2 to the power of 6 take away 1, all over 2 take away 1. That's what we need to do. Look at this over here. So it's 3 times. Now 2 to the power of 6 would be, so 32 times 2 would be 64. Take away 1, all over 2 take away 1. This is the same thing as saying 64 take away 1 is 63 divided by 1. So therefore it's 3 times 63 the answer. The answer would be...
So write this question down, press pause, press play when you are ready. So this question, we're dealing with 2 separate, let's say, accounts. One a cash account, one a shares account. Shares means stocks and shares. And this could definitely be something from the real world. So let's see what numbers we have over here. Okay, we have £3,000. This is being invested by Kobe in both bank accounts. Now, which one will give him the best rate? Now, this is something called comparisons. It comes up quite a lot, in fact. So let's look at the cash account. We get 3.5% a year here for 4 years. And this one, the shares account, is called a multi-step problem, multi-interest, let's say. It's 4% in the first year, 5% second and third. It's higher in this latter years just for customer loyalty. This is how banks operate, actually. So it's a real-life example. So what should he actually invest in, considering all other factors are the same? We're just looking at the monetary value at the end to analyze this investment. So the cash account, let's see. So what we'll do is this. We do 3,000 times 1.035, very simple, to the power of 4. So it's our basic setup using our 3 key numbers over here. Nothing difficult in that. And the answer is £3,442.57. So that's how much Kobe would make in his the cash account. Now, what about he's a bit more risky? Let's say he wants to invest in the stocks and shares account. Okay, so he does this. Kobe invests £3,000. Now he invests in the first year, he gets 4%, 1.04, a bit more for your money because obviously it's a bit of a higher risk. Now 5% in the latter 2 and 3 years. Now instead of writing 1.05 times 1.05, we'll just write 1.05 squared. Okay, because at 2 years it'll save you a bit of time. So this answer will be £3,439.80. That's how much it'd make over there. Okay, so let's obviously look at this and then base this investment just on the monetary terms. You shouldn't already in real life, but we'll just do it in this case. And which one is obviously higher, 3,442 or 3,439? It's obviously the cash account. Okay, because obviously it's the last year that's made it in the 4th year. So we're going to go with this one over here, and this is our final answer over here. Okay, so we would invest in obviously the cash account. Let's just write that to make it a bit more clearer. Cash. Okay. Press pause, write this question down, press play when you are ready. So again, the key information over here, these 3 key numbers, it's £4,500. That's what we started off with. 5% is how much interest this investment grows per year. And the amount of years we have here is N or X. That's how many years his term is for this investment. We have something else as well in this question. This number here shows how much the investment has grown to at the end of it. Okay, so the total capital accumulated at the end of X amount of years is 5,000 £5,743.27. So let's see what we can do now. This is more of a trial and error question in terms of like trying different numbers to get to that final answer. So let's try n is 4 first of all, and let's see what we get with this. So the basic setup is so critical over here. 4,500 times 1.05 to the power of 4. So if we do this, we're going to get 5469.78. Now, is this higher or lower? £5,469 than this. It's obviously lower. Okay, so we'll put too low over here. Let's try another number over here. N equals 6. So again, it doesn't matter if you put 7 or 8. They're not going to penalize you for that, as long as we try to whittle this down to our final number. So basic setup, 4,500 times 1.05 to the power of 6. Now, here this time we get £6,030 and 43 pence. Do these signs as well. So that is a bit too high. So let's try the number right in the middle. Let's try n equals 5 in this case. So 4,500 times 1.05 to the power of 5. And if we do this, we're going to get the exact number over here. And that's what they want, the exact number. So it's more or less trial and error. You got to try to figure out what is the best way to actually get this number. Okay. And it's not that difficult really if you understand what to do. Press pause, write this question down, and press play when you're ready. So again, we're looking for the keywords over here. Compound interest, which obviously is definitely going to be in the exam, compound interest, opposed to simple. And let's look for our 3 key numbers over here. So we have the initial amount, £5,500. We have our interest rate, which is X this time. We don't know this. The number of years is 5 years over here. And our money actually grows to this number over here, £7,029.35. So how can we do this? Let's create our setup. Always do the setup first. It'll always really help you. So this times, now we haven't got a multiplying factor here, so let's just call it x. An x to the power of 5, okay, because obviously they're 5 years, and we end up with this amount over here, 7029.25 to be exact. So we want to make x a subject. That's the whole point of this. That's what our intuition says. Let's do x to the power of 5 equals this number divided by 5,500. So this divided by 5,500 is going to be this over here, 1.2781. This is just the 4 decimal places I've done it to. Obviously keep the full number on your calculator, please. Anything in the middle within the process of any answer within maths should be kept in its whole form, okay? So what do we do with this? How do we reverse x to the power of 5? We'll obviously do the opposite or the inverse of this. We will actually root this, okay? So 1.2781 to the power of 1 over 5. Now remember, I put the whole number on the calculator over here, not that. This is just to make it easier for us now. So if we do this, let's see what we get. So we'll do this right now, in fact, and we get this number over here, 1.05. In fact, what I'll do, I'll write the whole thing down just so it makes sense to us. So x equals this. Now obviously we want a percentage over here. We don't want this multiplying factor. This is x in terms of the multiplying factor. If you look at this carefully and the answer says the 2 decimal places, the answer will be hidden over here. It'll actually be 5.03%. If you look at these numbers, okay, it'll be quite self-evident. So please make sure you go through that, you understand that, because that could easily come up as well. It's quite a challenging question, how to find out the hidden percentage rate in a question.
Question 7, Core 7 Silver, Sequences and Series. Press pause, write this question down, press play when you have found out A, the first term, and D, the difference. So this question, we're dealing with 2 different, let's say, terms within the arithmetic series, and we're trying to make, let's say, them equate each other to find out A and D respectively. First term, okay, and let's call D the green one over here. Okay, so this one signifies A1, and this one is D over here. So first of all, we're looking at this. The 4th term is 25. Now you know that the nth term of the arithmetic series is this: AN equals A1 plus N minus 1D. Let's plug in a few numbers from this. So A4 will equal A1 plus 4 take away 1 and D. Okay, the A4 is simply going to be this. A4 is going to be this number over here. See, 25. Okay, so I'm going to write this. This is such. So 25 equals A1 plus 3D. Okay, so this is number 1 over here. Let's formulate the same thing we did for the second part over here, which will be this one over here. Okay, the 7th term is 43. What can we do with this one over here? So again, we've got A7 equals A1 plus, this is the 43rd term. So we're going to do, well, still 7 take away 1 over here, D. A7 is 43, so 43 will equal A1 plus 7 take away 1 is 6, 6D. So this is number 2. So these are very important 2 equations over here. We have this one over here and this one over here as well. Okay, so to look at. Let's put them underneath each other. This is, guess what, a simultaneous equation. So number 1, we'll write it like this. A1 plus 3D will equal 25. And number 2, we can write A1 plus 6D will equal 43. Let's take them away from each other. The 2 like terms here are A and A, A1 and A1. Let's go bottom take away the top one. Okay, each one of these respectively. So this is forward slash 6D take away 3D is simply 3D. 43 take away 25 is going to be 18. So therefore D would equal 6. Difference is 6. Sum in this value of D into the easiest one. Let's say it's number 1 over here to find out A. So we'll get A1 plus 3 times 6 equals 25. A1 equals, apologies, A1 plus 18 equals 25. So A1 equals 25 take away 18 is 7. So that's your first term over here. So our 2 answers are going to be this. The first term is going to be A1 is 7. And the difference is 6. Okay, it goes up each time. You can test it. Starting with 7 and adding it up each time. You don't have to do that, but basically we say this. If 7 is the first term over here, you keep adding 6 each time. So 13, 19, 25. We go on and on until we hit that number as well. Anyway, hope you got this. Make sure you get the simultaneous equation and get this question. Question 8, core 8, silver, sequences and series. Press pause, press play when you have finished this question. So the 3rd and the 5th terms of a GP are 32 and 128 respectively. Let's color code these 2 things over here. 32 and 128. Find the common ratio, okay, and find the first term of this GP as well. So basically it's finding R and G1. So what's the nth term of a geometric? It'll be this Gn equals G1 and R to the power of n minus 1. Okay, let's plug in a few things over here. Let's plug in the 3rd term. So the 3rd term is 32. 32 is G1. We don't know that. We don't know what R is as well. We do know it's the 3rd term, so 3 take away 1. Okay, I'll put 3 take away 1 over here. So 32 equals G1 and R squared. In the same way, I'm going to be doing the same thing for the next one over here, which is the 5th term. So we have, let's say, in this case, the color code here. Okay, so you just know this is going to be this one over here. We'll do the green one now, which is going to be 128. So 128 equals G1, and this will be R. This is the 5th term, so 4 take away 1, or 5 take away 1 rather, getting a bit ahead of ourselves, equals G1 and R to the power of 4. So this is the same thing as putting the green 128 over here, the 5th term. Now let's see what we get with this. This is number 1. Number 2, let's write this a bit better in terms of simultaneous with the division. So number 1, well, I write the 128 first, in fact, over here. Okay, so in fact, yeah, let me write this as 128 first. 128 equals, so G1 R to the power 4, and number 2, I'm going to write 32 equals G1 again over here, R squared. Okay, this is simultaneous with division, okay, so let's divide the top by the bottom. So 128 divided by 32 will give us 4. G1 divided by G1 will give us 1. Again, R4 divided by R2. When you divide indices, you take away the powers. 4 take away 2 is going to be squared, R squared. Therefore, R would simply be square root of 4, which is 2. So if R is 2, let's plug this back in again now to find the R of the corresponding value. The other one would be G1 over here. Let's just underline this so don't forget. This is R2. So G1, let's plug in what was easiest over here. I think it's number 2, equation number 2, we'll sum this number 2 over here. So 32 equals G1, and this is 2 squared, okay, because this 2, what's this 2 over here? Okay, so 32 equals 4G, therefore G1, so the first term, this geometric would equal 32 divided by 4, which would be 8. Okay, so this is how you do this for this one over here. So we've got the first term as 8, and the ratio is 2 every time. Okay, you can test it as well, but we're going to just write those two answers as here. What AR is and what G1 is. Question 9, core 9, silver. Press pause. Let's write this question down on sequences and series. Let's try to find the arithmetic series for the summation of this. Press play when you're ready. So this question, how many terms of the series 7, 11, 15 are needed to make the sum of 1, 6, 8? That's the question, okay? So this is the summation formula for the arithmetic series. So Sn equals n over 2. This is 2a plus n minus 1d. Okay, so what we've got is this. You make this capital N if you want to as well. We've got the summation, which is 168 over here. So 168 equals n over 2. Now a is going to be, or a1 rather, will be 7 over here. So 2 times 7 is 14. Okay, n we don't know, n minus 1. D is the difference. It goes up in 4 each time, so plus 4. I'll put the 4 in front, n minus 1 as such. Now you can do this. You can put a 1 underneath here. You'll see why in a second, because basically we can use a cross multiplication. This is the same thing as saying, if I multiply this whole thing outside, in fact, 14 plus 4n minus 4. This whole thing can be written over 2, okay, because this allows us to cross multiplication over here. So just remember that technique. In this case where you have to make n the subject, you can make that denominator of the 2 here as a big 2, because this is actually all over 1 if you think about it. 2 times 1 is 2, same concept. So a 168 times 2, this will give us 336. Let's just write this down over here. So 336 will equal n, and this is going to be 14 take away 4 is 10 plus 4n. Okay, let's multiply that out over here. So 336 will equal 4n squared plus 10n. This will form a quadratic. 4n squared plus 10n minus 336 equals 0. So this is the key information over here. How do we figure this out using a quadratic? Okay, to find two values of n. We can divide the whole thing by 2. So 2n squared plus 5n minus 168. Okay, so let's just try to figure this out. Two numbers multiply to get, this is an advanced quad box. Two numbers that multiply to get 336, and add up to get 5. Okay, this is called the advanced quad box. So how do we go about this? So we figure this out. We'll leave you to figure this out, these numbers yourself, on maybe a prime tree diagram. But what two numbers multiply to get minus 336 and add up to get 5? That's the question. It'll be 21 and minus 16 if you figure this out yourself. Minus 16 over here. Let's now ignore this and carry on with this. We have 2n squared. We're going to write minus 16n plus 21 and minus 168. Okay, these two things will represent the 5n over here. Factorize this, so 2n over here, and we get n minus 8. Okay, we write n minus 8 again over here. This will be 21. Okay, so 2n plus 21 is one bracket, so two numbers at the front of this, and this is n minus 8 over here, equals 0. So n will basically be minus 21 over 2, which doesn't really exist, or n would be a value of 8. So n is 8, that's the answer for this. The sum of the first 8 terms of this arithmetic series will give you n equals 8. That's how you do this. It's quite a tough topic if you ask me. But this is how you do it. The key thing is this, the whole thing is over 2 if you ask me. Look at this key understanding of this, why this is over 2, how we got from this to this level. Very important how we got to a quadratic over here by dividing by 2, advanced quad box, and we can't have a negative n, we can't have a negative term. Positive n is the answer for this one over here. Question 10, core 10. Press pause. Let's write the silver question down on sequences and series. Press play when you have done it. So this is all about a geometric progression and finding out the nth term over here, which we have a certain summation of 21 over 4. So how many terms will you need in this geometric progression to get to this number over here? Okay, we're given two things over here. We're given the first term, which is, let's say, 4, and the common ratio, which is a quarter over here. Let's find n. So let's rearrange, or let's write down first of all this formula for the summation of a geometric series. This will be g1 over here, and 1 take away r to the power of n, and 1 take away r. Why is this the other way around? Because over here the ratio is less than 1. Okay, if it's less than 1, if a quarter is less than 1, therefore we use this one over here. So basically we have 21 over 4 equals, the first term is 4, and this is 1 take away a quarter, because the ratio is a quarter, n, and this will be 1 take away a quarter over here. It's the same thing as saying 21 over 4 equals, if you want to say this, you could say that this will be 4, and this will be 1 take away 1 over 4 to the power of n over 3 over 4. Okay, this is imaginary 1 here. You can do that. Now this is the same thing as cross multiplication. 21 times 3/4 will equal 4 times that number at the top right as a fraction. So we could say over here, if I bring this over one more step, we could say 21 times 3/4, so 63 over 4 basically will equal 16. 1 take away a quarter again to the power of n, as such. This is the same thing as like 63 over 64 will equal 1 take away a quarter to the power of n over here. Okay, so basically now what we could do is this. We could just swap these around. We could say, if you see this, 1 quarter to the power of n will be the same as 1 take away 63 over 64. 1 quarter to the power of n will equal 64 over 64, same denominator over here, over 64, which in turn will basically be 1 over 4 to the power of n will equal 1 over 64. Okay, now what is the value of n? N to the power of what gives you this? Well, obviously it's going to be 1 to the power of n gives you 1. 4 to the power of n gives you 64. So it'll be 3. N will be equal to 3 over here. We can just see that. So the third value in the sequence basically will give you a sum of 21 over 4. If we start with 4, we can test it basically. 4 is the first term. Second term would be 1 if times by a quarter. The third term as well times that will be a quarter as well. If you add them together, you should get 21 over 4. But this is the third sequence, proving that n equals 3 over here. This 3 equates to this 3 over there. Question 11, core 11, silver. Press pause. Let's write this question down to find the value of x in this geometric progression and the geometric mean. Press play when you are ready. So given that this progression has 16x and 169 as consecutive terms in the geometric progression, find the value of x. So in this question we have to identify the ratio that multiplies each term in this geometric progression. Now this is times by r, and this is times by r. That's the same value r. What is that value of r? How do we do that? To determine r, we have to divide, let's say, the third and the second term. Okay, so 169 over x. That will give us r. Okay, and also x over 16 will give us r as well, because it's snap r equals r. So therefore we can say this: what x over 16, second divided by the first term, will equal 169 over x, a third divided by a second term. Okay, to find x we can cross multiply now, so we can say basically that x times x over here will equal 16 times 169. So if we do that, let's do the maths over here. So we're going to get a value of x squared equals 169 times 16. Now, non-calculator, how do we do this? Well, anyway, how do we square root this? The square root of 169 times 16 is simply going to be the square root of 169 times the square root of 16, which will be 13 times 4. So 52 would be the answer over here. 52 would be the value of b, the second term in this sequence. Okay, so it's basically just finding the value of r, which is the same for all the terms, and using the division on those respective terms, and therefore cross-multiplying, always cross-multiplying it. That's how we find out x. Geometric mean is defined as this, so a plus and minus and a times c. What do we mean by a times c? Well, these are the first three terms of the sequence: a, b, c. A is 16, b is x, and c is 169. So we already did the answer to this actually in part 1. So A times C would be 16 times 169, which would be plus and minus 16 times the square root of 169, which would be, again, 4 times 13. So therefore the answer would be either a positive or a negative 52 for the geometric mean. Again, very similar to the one derived in part A of this. Question 12, core 12 gold. Press pause, write this question down. Let's try to find out A and D in this arithmetic progression. Press play when you are ready. So the fifth term of an AP, let's call it, is 21 greater than the second term. Okay, the 10th term is 50 times the second term. Find the common difference and the first term of the arithmetic progression. All right, so they're not giving us many numbers over here. It's all about multiples of each other regarding terms in this AP. So let's look at this. So the fifth term, A5, okay, is defined as A plus n minus 1d. N is 5, 5 taken away 1 is 4, so it's 4d. Okay, so A5 equals A plus 4d. Let's define the second term over here. A2 equals A plus n minus 1d. N is 2, 2 taken away 1 is 1, so it's just be 1d or d over here. Alright, so this is the first two lines we have so far over here. Okay, so we've got this the first line we have over here, but it's the first two statements. Now, what we want to do is look at this 21 over here, because it's 21 times greater. So therefore, if A5 is 25 times greater, we need to add 21 onto this one over here. Okay, add 21 onto this one to make them equal to each other. So we can say basically that A plus 4d equals A plus D plus 21. Okay, so they're all balanced together. Let me just rub this one off so it makes sense. Okay, do you remember that 21 is to balance it in one go? Okay, now we can work out D from over here without even going to the second statement in this question, because we can say A's and A's cancel. 4D take away 1D will equal 21, so 3D equals 21 and D will equal 7. The difference is definitely going to be 7 in this question. Let's carry on to our second statement and see what we have over here. So the 10th term. So again, same thing we did for the last statement. A10 equals A plus n minus 1d. N is 10. 10 taken away 1 is 9. A plus 9d is defined as this. Now this is 21 times the second term. Your second term, remember, is A plus D, which is over here. Remember, this is what we talked about before, A plus D over here, second term. So therefore, we need to multiply A plus D by 15 to get to this, okay? That would make sense, because in that way, we make them balanced or equal to each other. So we can say to ourselves, 15 times the second term, which is A plus D, will equal the 10th term, A plus 9D. Let's see what we can do with this. Let's half crap all this. 15A plus 15D will equal A plus 9D. Let's call the D's on one side and the other one. So 14A will equal 6D over here. Now D, we're told, was 7. We had 7 over here, right? So 14A will equal 6 times 7, 42. A will equal 42 over 14. And therefore A will equal 3 in this case over here. Well, actually it's minus 3 because we made a little blunder over here. This should be minus 6D and minus 42, because 9D take away 15D was minus 60. My apologies. So anyway, so A is minus 3. So there we go. A is minus 3 and D is 7. You can test it if you want to, but write them down. You don't have to. If that's the first term, we go by 7 each time for adding 7 to this, 11, 18, 25, 32, 39, 46, 53, 60. Okay, tested me there. So basically this is the first term, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Okay, fifth term, this is definitely 21 more than 4. And it's the 10th term, 60 is definitely going to be 15 times more than the fourth term. So second term, which is 4. So we've tested those are your answers.